Okay, in this video we are going to be looking at question 11 on the WJC additional maths paper from June 2015. So we start with a right square based pyramid. It has a perpendicular height of 12 centimeters. So that means that the distance from the base to the peak is 12. Now, looking at this in terms of how we can draw it, it's from this top point here right the way down to this point here. Now we're going to make an assumption, because of the way it's a right square base pyramid, that point is directly in the middle. So we are going to assume that this point here, or we're not going to assume, we know that this point here is exactly in the middle of that square on the bottom. So that is 12 centimeters. The area of the square base is 64. So that's our other important piece of information. So we've got the perpendicular height of 12 and the area of the square base is 64. We want to calculate the angle between the diagonal of the base and one of the sloping edges of the pyramid. So let's just figure out what that means. The diagonal of the base means the length that goes from one side, one corner, all the way through to the other corner. So that's our diagonal. And the angle between this diagonal and one of the sloping edges is going to be this value there. So we come out with a right angle triangle by here. We know the one side is 12. What we need to be able to do is to work out this side. It could be this side here, but they wouldn't talk to you about the diagonal of the base if they didn't want you to find the diagonal of the base. Okay, so that's what we're going to be looking at. So if we take a look at that base, we know it's a square. And we know that the area is 64. So if the area is 64 centimeters squared, and this is a square, that means that each length has to be the square root of 64. So each one of these is going to be 8 centimeters. So that's 8 centimeters. That's 8 centimeters. So the diagonal that we're looking for is this length here. Okay, so that matches up with this length there. We can we can find by using Pythagoras. So using Pythagoras, which says a squared plus b squared equals the hypotenuse squared, then a is 8 and b is 8, and the hypotenuse is this value that we don't know, so I'm going to keep it as h, all squared. So I work out that left-hand side. 64 plus 64 is 128, is h squared. So then if I want to find out what h is, I need to find the square root of 128, and I'll keep it in surd form, 8 root 2. Okay, so now I know that this entire length here is 8 times root 2. Now, I only need half of it. So half of 8 root 2 is 4 root 2. Okay, so that means that if we come to this right angle triangle, we know that this was 12. This length here is 4 root 2. And we are looking for this angle in here. So this is our basic trigonometry. So this is our hypotenuse again over here. This is adjacent. This is opposite. So if we're looking at our SOHCAHTOA, the one that we're not using is h. So it's going to be using TOA, which is tan theta equals the opposite over adjacent. So if I put in what I know and what I don't know, so this theta I'm trying to work out, the opposite is 12 over 4 root 2. And then to find out what theta is, I just need to find the inverse tan of 12 over 4 root 2, which I can put into my calculator. So inverse tan of 12 over 4 root 2 is 64.8. Let me just check. Doesn't ask for any particular format or any particular number of decimal places. So I'm okay to write 64.8 degrees to 1 decimal place.